All right, welcome to section 6.3 on showing quadrilaterals are parallelograms. So basically this is the converse of what we were doing in section 6.2. In section 6.2 we were given a parallelogram and then we knew all of the different little theorems about it. This time we're going to be given, a situation where now can we determine if it's a parallelogram or not? It's the converse. And so the first theorem in this section is theorem 6.6. If both pairs of opposite sides of a quadrilateral are congruent, then we know it's a parallelogram. So if we know the opposite sides are congruent, we know it's a parallelogram. Theorem 6.7, if both pairs of opposite angles, if both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. So if you know either the opposite sides are congruent, all four opposite sides, or all the opposite angles are congruent, then you know they are parallelograms. All right, tell whether this is a parallelogram. Looking at this, I know that these two sides are congruent. I know these two sides are congruent, but because they are not opposite sides congruent, it's not a parallelogram. And that's a symbol for parallelogram. Okay, so it is not a parallelogram because the opposite sides are not congruent. The consecutive sides are, and that's not correct. All right, tell whether the quadrilateral is a parallelogram. Okay, so we know that this one is 40, this one is 40, this one is 140, and this one's 140. So yes, it's a parallelogram because opposite angles are congruent. That's all you have to do when you explain your answer. Just put down the basics of that property or that theorem, and this is exactly the type of answer I am looking for on your homework. All right, here's a checkpoint. This is what I would like you to try. So go ahead and pause your video and then do these three problems and see how you do. We'll check them here when you're done. Okay, welcome back. Go ahead and let's check our answers. It says tell whether they are parallelograms. We have 4 and 4. They are opposite sides and they are congruent. We have 5 and 5. They are opposite sides and congruent. So yes, it's a parallelogram because opposite sides are congruent. Yes, it's a parallelogram because opposite sides are congruent. This one, we have opposite angles here are not congruent. They are not congruent, so this is not a parallelogram. Opposite angles not congruent. Okay, so that's how you would explain your answer. All right, number 3. In a quadrilateral WXYZ, so you might want to draw that. W, X, Y, and Z. It says WX is 15, YZ is 20. So that right there tells me that it is not a parallelogram. XY is 15 and ZW is 20. So this is not a parallelogram because opposite sides are not congruent. Okay? Opposite sides are not congruent. All right, theorem 6.8. If an angle of a quadrilateral is supplementary to both its consecutive angles, the angles next to it, so both sides, then the quadrilateral is a parallelogram. So in other words, if y and x are supplementary and these two are the same, so this one is also supplementary, then it is a parallelogram. Okay, so tell whether the quadrilateral is a parallelogram. 95 plus 85 is 180. And of course, 95 plus 85 is also 180. So yes, it's a parallelogram because consecutive angles are supplementary. Yes, parallelogram because consecutive angles are supplementary. Okay, this one we can say right now is not a parallelogram because these are opposite angles not congruent. Okay, this one we don't know. We don't know that the opposite angles are congruent. I'm just putting down opposite angles are unidentified as being congruent. Okay? The last one, I believe, is the diagonals of a quadrilateral bisect each other. Then the quadrilateral is a parallelogram. Okay, so here it basically says that if you have diagonals that are split up in two by each other, then it is a parallelogram. So when we look at this one here, 19 and 19 are the same. 18 and 18 are the same, so basically the diagonals do bisect each other. So we know that it is a parallelogram because diagonals bisect each other. This one here, 2 and 3, the diagonals are not bisecting each other because that diagonal is not split up in two. The diagonals do not bisect each other. Okay, so now again, take time to pause the video and then we will go over it when you are done. Okay, again, welcome back. Let's go over this. This one, rather than saving time by writing it, I'll just explain it here and hopefully you have it written down. It says tell whether these are parallelograms. This one is not because the opposite angles are not congruent. Number 5 is opposite angles are congruent, but we got to look at consecutive angles supplementary. And if I added these two up, that add up to 180. If I add these two up, they do add up to 180. So this one would be yes, because because consecutive angles are supplementary. This one is a parallelogram because the diagonals bisect each other. Okay, diagonals bisect each other. This one is not a parallelogram because they are not bisecting each other. All right, here again is a summary page of all the different things to be able to show whether a quadrilateral is a parallelogram. If you know any of these things, you know that that is a parallelogram. And that's it for section 6.3. Let me know if you have any questions via message or email.